All right, we are in section 7.2, and the title of this is Integration by Parts. Now, when we do derivatives, we had product rule, quotient rule, and all these special rules, but we don't have that with antiderivatives, integrals. So it makes it more difficult. I'll give you an example. So if you have this integral, here's the problem. We don't have something called the product rule. So we can't have a magic formula. And so the first thing you have to look at is there a U substitution I can try? Is there some subtle substitution? Is there a way I can rewrite it? So you should always look for that first, is rewriting, making it a problem that we can do. So you might say, hey, let's try this, a U substitution, then du would get you e the x dx. And here's the problem. If we make this du, we don't have a u because all we have here is an x. So that doesn't work. And if we make this the u, I don't have du. And so it doesn't work. And so we have to keep trying things, and you're going to find, wow, I can't find anything. What am I going to do? So in that situation, when you have exhausted all other possibilities, we have a possibility of integration by parts. So I'm going to show you how to do this. I'm going to give you a basic formula here. Let me write it down. So you have to have it in a certain form. The integral of u dv, we call it ultraviolet voodoo. It's uv minus v du. So what we have to do in this problem is we have to pick a u and a dv. So the dv is going to have the dx part of it. It's going to be in differential form. So one of these with the dx, or the x with the dx, or the e the x with the dx, or maybe only the dx all by itself will be our dv. But probably not all by itself, because then you're just changing the variable. You're not really helping yourself. So we will give you a secret of how to decide. In fact, I'll do it right now. So this is your integration by parts. Let me box this. This is your secret formula. And again, the ultraviolet voodoo. It's kind of mnemonic to help you remember. Ultraviolet voodoo. So here's the next thing that you should know. We're going to do LIATE. And what is LIATE? This is to select U. Another mnemonic. So first, you look for any log functions. Then you look for inverse trig functions. Then you look for algebraic or polynomial. Then you look for trig functions, and then exponential. And this is to choose. I'll do a different color for all y'all. This is how you're going to choose u. So if we look at our example, the first one that we have down there, do we have any logs? So any log functions? No. Do we have any inverse trig functions? No. Do we have algebraic or polynomial? Yes. So we have an x. So our u is going to be x. Whatever's left over is going to be our dv, because our original integral has to have a u and a dv. So I'm going to put dv down here and have it be everything that's left. And we have to find the missing parts. So we have to find v and du. Well, du is pretty easy. The derivative of du is just going to be dx. Now, we have to take the antiderivative of this and go backwards. So we ask ourselves, the derivative of what is e to the x? Clearly, it's just e to the x. So now we have our uv, du, and dv, and we are going to use this formula right here to plug it in. So this is ultraviolet voodoo, or actually integration by parts. So the integral of x e to the x dx is going to be ultra, which is u, and we see u right here, so that's just going to be x. And then violet v, well, v is right here, it's just going to be e to the x minus integral of voodoo. V is just e to the x, and our do is dx. So now we have x, e to the x, and what's the antiderivative of e to the x? That's e to the x. So, bam! I have found the antiderivative using integration by parts. That is my final answer. All right? So I'm going to put one up here for you. Yeah, hopefully you took notes on that, because I need to scroll up on the screen. Actually, you know what? I can be nice to you guys. This is example 1. I'll put example 2 right here, and then I'll scroll after. So let's see if you can find the integral of x sine x dx. You should pause the video now, try this problem using the rules we just did, and then start it again and see if you chose rightly. All right, so the first step is we have to choose u. We're going to use LIATE. Do we have any logs? No. Do we have inverse trig functions? No. Do we have algebraic or polynomial? Yes. So once again, we're going to choose u. I choose u. So u will be x. The derivative of v is everything left over. And now we have to find du, and the derivative of x is just going to be dx. And the antiderivative of dv, the derivative of what is sine? And you may say cosine, but double checking, the derivative cosine is opposite sine, so to make it right, we need that. Okay? Now we just apply the ultraviolet voodoo. All right, so ultraviolet, ultra is x, violet is minus cos x, minus voodoo, the voo is minus cos x, and the do is dx. LIATE, we're on our way. These two minuses here get us a plus. And we find the antiderivative cosine, and we ask ourselves the derivative of what is cosine? And clearly, that's sine x plus c. So, 'tis our answer. All right. We will just keep on doing more examples. Pretty much that's integration by parts. There are other things that happen, and we also have definite integrals. So let's continue and see what happens in this next situation. All right, so this is example 3. Now I expect you to have problems with this, and I will show you the secret, but you're gonna have an issue, maybe, probably, unless you've seen this before. So go ahead and pause, try to do this, and just a warning, you might get a little frustrated, but do your best and come back and I'll explain this all to you. All right, so again, we have to pick u. So we are going to use LIATE. And there's actually another one that people use instead of LIATE. So you might, if you go online and search integration by parts, you'll find another mnemonic. So they both should work, slightly different. So do we have any logs? We do not. Do we have any inverse trig? We do not. Do we have any algebraic? Oh, we have an x squared. So u is x squared. And everything else will be the derivative of v, so that's e to the x dx. Now we must find what v was and find du. Well, du, derivative of x squared, is 2x dx. And the antiderivative of e to the x is just e to the x. Bammo. All right, you're all excited because this seems pretty easy. And you get your original integral. And you say, hey, ultraviolet, u is x squared, v is e to the x. Hey, that's pretty easy. Vu is e to the x, and du is 2x dx. And here's the sad part. We don't know the antiderivative of this. And we can't do a u sub, we can't do a rewrite. So this is called repeated integration by parts. So you have to do integration by parts again on what's left. So we're going to do side work. And I'm going to do my side work on the bottom because I don't have much room on the side. So we need to find the integral of e to the x times 2x dx. All right, we go through our LIATE process. We don't have logs. We don't have inverse trigs. But we do have algebraic again. So that will make our u is going to be our algebraic part. And everything left will be the derivative of v, which is that. And the derivative of u, well, that's going to be 2 dx. And another option, you could have put the 2 out in front because it's a constant, or you could leave it in. It'll work out either way. And the antiderivative e to the x, e to the x, I got that. So we do ultraviolet voodoo. Ultraviolet minus the integral of voodoo, do. All right, I'm feeling much better now. That's 2x e to the x minus 2, that's a constant. I'll pull it out front. And now I am on my way to San Jose. The antiderivative e to the x is just e to the x. All right, technically there's a plus c, but we'll put that, yeah, I better put the plus c here, not to freak you guys out. So that is the antiderivative of that. So I'm going to plug this in for that, if it all makes sense. So I have x squared e to the x minus, and in parentheses, because I'm subtracting this whole antiderivative, it's 2x e to the x minus e to the x plus c. Whoa, that was crazy. X squared e to the x, distributing the minus, I get minus that. Distribute the minus, I get plus that. If I distribute the minus, I get a minus c. We'll call this c1, which is just some constant. But it's just a constant, so that's why I was reluctant to put it in there. But I'm going to make it plus c. And c is just opposite of c1. It's just a different constant. One's positive, one's negative. So it all comes out the same. All right, that should be our answer. I will double check to make sure it matches correctly. X squared minus 2x. Oh, Yoshida, I messed up, I think. Yeah, back up a little bit. Good thing I checked. See this 2 here? It should have been there also. Okay, the only thing that the book did, they factored out the e to the x since all of them have an e to the x. And they got that answer here. Now, I highly recommend you do side work. If you all try to do it in the very beginning problem, it gets very confusing sometimes. So I would do side work, find your answer, and then put it back into the original. So that is repeated. And sometimes you might have to do it 3 times or 4 times or 5 times or 100 times. I'm not going to be mean to you like that. The most I would give you probably on the homework is 3, but I don't even know if I'd do that. I would avoid doing that, but I don't want to promise you because I might accidentally give you one and not on purpose. Okay. So I'm going to give you another one to try. So I'm going to write this down, pause, and then you can try this out. This is a good example because your LIATE will be different this time. So go ahead, pause the video, and try to do this problem and see what happens. Okay, and this one's another special case. So you're going to get frustrated. So do your best, but it's a learning process. So you're going to learn. You're going to be on your own tomorrow. I'm not going to be with you. And then on Monday, we will finish up talking about this, and then we'll move on to our next topic, another integration technique. But this one's not bad. It's just kind of weird, and it takes practice. So go ahead and try this. All right. Hopefully you were somewhat successful. Once you get this process, it's pretty easy. So we need to pick u. Do we have any log functions? No. Inverse trig functions? No. Algebraic? No. Trig? Yes. Yes. So u will be our trig function, sine x. Everything else left over will be our dv. So that's e to the 2x dx. And now we have to do a little bit of thunking. The derivative of u, derivative of sine, I know that, cos x dx. Now we have to take the antiderivative of e to the 2x. Now be careful because technically it's a u sub. U needs to be 2x, and you might have to do this on the side. Du will be 2 dx. I don't have a 2 dx. You end up with a 1/2. So if you're confused right now, you need to do this as side work. And that is v. You can double check, because what's the derivative of e e to the 2x? It's e to the box times the derivative of the box. Well, e to the box we have here, the derivative of the box is 2. But the 2 and that 2 cancel, give me my 1. So that's the double check on that. All right, let's move to the next step. We're getting excited. Ultraviolet voodoo. Ultra is sine x. Violet is 1/2 e to the 2x minus the integral of voodoo. And now we are sad. Because if you look at this thing, again, it's not a simple integration. So we have to do some side work, and I'll do it on the bottom. I'll work out this integral down here. The 1/2 I'm going to move out in front. What just happened? I don't know. So the 1/2 I move out in front. It's going to leave me with e to the x cos x dx. We go through LIATE. U comes out to be cos x. dv is everything else left over. du would be minus sine x dx. And v, did I forget? Oh, poopers. There's a 2 there. There's a 2 there. So it's, for the same reason the previous one's going to be 1/2 e to the 2x. Now we do our ultraviolet voodoo on this. The 1/2 is out in front. And now I have cos x is my ultra. 1/2 e to the 2x is my violet. Minus the integral of voodoo. My voo is 1/2 e to the 2x. And my do is minus sine x dx. There's a lot of stuff going on. Make sure you're careful with your parentheses and all that good stuff. And so I have a 1/2 cos x e to the 2x. And then you'll notice there's 2 minuses, one here and one here. Let me combine that to a plus. I'm going to pull that 1/2 out in front. And I'm left with e to the 2x sine x dx. And I'm sad again because, ooh, I don't know that. That's not, I got to do ultraviolet voodoo again. Now, if you kept going, you will be in an infinite loop and you'll be stuck. So this is a special case, and pay attention. What I'm going to do next, do you see there's a half in both these? Am I going to do this, or am I going to distribute that half? Let me distribute that half. Let's do that. So I'm going to get 1/4 cos x e to the 2x plus 1/4 integral e to the 2x sine x dx. I'm going to take this answer and plug it back in way over here for that integral. And something magic is going to happen, and hopefully you get excited about this. So I'm going to start from the beginning. The original problem was e to the 2x sine x dx equals, then I'm going to take this part and write that next. So that's going to be, I'm going to put the 1/2 out in front. 1/2, so sine x e to the 2x minus, in that whole thing I found down below. So I get 1/4 cos x e to the 2x plus 1/4 integral e to the 2x sine x dx. I'm going to put a plus c at the end of that whole thing. All right, hang in here. Here's the good news. Maybe someone's going to see it, maybe not. I'm just going to distribute this minus sign here to both of those, and something magic's going to happen. It's going to happen. If you see it, I guess you can't say anything because I won't hear you, but give yourself a large cheer. It's a minus because I'm distributing the minus. Give yourself a very loud cheer if you see it. Do you see it? Do you see it? Do you see the magic? You can pause. I'm going to tell you what it is if you don't see it, but you can pause and try to see it, but I'm going to tell you right now. So here it comes. Look at this and look at this. What do you notice? They're the same. So here's the magic. I'm going to add this to both sides. I'm going to add it to this one also. I'm just doing my algebra skills. And watch what happens. 1 1/4 is 5/4. Ooh, it was the wrong color, but e to the 2x sine x dx equals, and then I have this part, 1/2 sine x e to the 2x. I have that part, minus 1/4 cos x e to the 2x plus c. Now, what was my original problem? My original problem, I was trying to find that guy. Well, I have that guy right here. I just have to get rid of the 5/4. So I'm going to multiply both sides by 4/5. If I do that, 4/5, the 5/4 is going to disappear. And I multiply everything on the right side by 4/5. So if I'm 4/5 times 1/2 is 2/5. 4/5 times 1/4 is 1/5. And here where I'm getting a little tricky. 4/5 times c is 4/5 c. That's just a constant, so I'm just still call it c because we just have a constant out here. Let me fix my 5. And that is repeated integration by parts, but then you recognize the integration on the left is the same as the integral on the right, so you can combine those, and bada bam, bada bing, we get this beautiful answer. The book factored out stuff, so I'll show you the final step of the book. Wow, I'm going to draw a line here because this is my side work. I don't want to get in the way. They factored out a 1/5 e to the 2x because this is a common factor. And then I'm left with 2 sine x minus cos x plus c. So there you go. That's integration by parts repeatedly, but then the special case is when your integral on the right and left are the same, you can just move it over. All right, I have one more thing to show you. One more. Actually, I'm going to do two more. Two more examples. Nothing new here. All I'm doing is we're going to have an actual definite integral. So how to deal with that. So here's our next example. Uh-oh, SpaghettiOs. You'll see what's going on. So LIATE. LIATE. Do we have any logs? We do. So that makes u, ln of x, everything left over is dv, which is only dx. So du is 1 over x dx, You all should know derivative of ln of x is 1 over x. And the antiderivative of dx is just x. All right, let's do this. Let's do this. All right, ultraviolet. Ultraviolet, that's separate, but it's from 1 to 2, minus the integral from 1 to 2. So it's just like before, using the fundamental theorem of calculus. You plug in the upper limit and then the lower limit and subtract. And then we're left with the voodoo, not so bad, eh? So let me rewrite this to be less confusing. There we go. And these x's cancel. That comes out to be 1. The antiderivative of 1 is just x. And here we go. 2 ln of 2 minus 1 ln of 1 minus 2 minus 1. I'm just doing fundamental. Ln of 1 is 0. If you don't remember that, you need to review logs, the graph of the log and the log of 1. So we have 2 ln of 2, and 2 minus 1 is 1, minus 1. And that is our answer. So that's how you do a definite integral. You need to put the bounds in the ultraviolet part and in the voodoo part. All right. Shall we do one more example? Yeah. Try this. This is the last one. That's integration by parts. That's what you need to know. I'll give you a couple problems to try. Monday, in class, I'll go over those with you and then give you a few more to try. And we're done with integration by parts. Tuesday, you'll get a new video. And I might post some solutions for you. Let's try this one. And I'm kind of scared because I didn't pre-try this, so I don't have the solution in front of me. But let's try LIATE. Do we have any logs? We do. 'Tis you. Whatever left is dv, so that's dx. du is 1 over x dx, and the antiderivative of dv, or dx, is just x. All right, let's do this. Ultraviolet. That's going to be, I'm going to rearrange these so it's less confusing. X ln of x is ultraviolet minus the voodoo. Oh, wait, did we just do this? Am I on drugs? Oh, I am so on drugs. Sorry, we just did this. That's so funny. But, okay, let's just finish this. Wow, I'm embarrassed right now. Very embarrassed. X, 1 over x dx. So this is x ln of x minus x plus c. So the reason I did that, the book has a theorem. Now you should know the antiderivative of ln of x is x ln of x minus x plus c. It's something that they'd have you memorize, but if you don't have it memorized, you would just do integration by parts. That's the end of the lesson. We are done-o. Man, I hope that wasn't bad. I hope that made sense to you. All right. Goodbye.